In question number 14, we are given an LCR circuit with an AC source. We are given R, C and L. We are given epsilon 0 50 volt and frequency 50 by pi hertz. Find the RMS current in the circuit and the RMS potential differences across the capacitor, resistor and inductor. And then final there is a noting about it. So let's solve the first part. So first thing we need to do is find the RMS current, and to find the RMS current we will have to find the impedance of the circuit. So this is R, this is L and this is C, capacitor C driven by an AC circuit. So the impedance of this circuit Z will be square root of R square plus omega L minus 1 upon omega C whole square. That is the impedance of this circuit. Now if we find the impedance, we can find the current flowing through it. R is given as 300 ohm, 300 whole square plus omega is, now let's find out omega, because omega frequency is given 50 by pi. Frequency is 50 by pi. So omega is equal to 2 pi f, and 2 into pi into f is 50 by pi. Pi cancels. Omega is given as 100. Now you can substitute this omega value here. It simplifies this. 100 into the inductor value is 1 Henry minus 1 upon omega is 100, and the capacitance value is 20 microfarad. 20 into 10 to the power minus 4, this thing whole square. So 10 to the power minus 4, 1, 2, 3, this becomes 10 to the power minus 6 because it's microhenry. 1, 2, 3, so this becomes 10 to the power minus 3 and goes up, becomes 1000, and 10,000 divided by 2 is 500. 100 minus 500 is 400. So this becomes the square root of 300 square plus this is 500, this is 400 square, and this will be equal to 3 square plus 4 square. Square root is 5 into 100. This is 500. So we know that the impedance of the circuit is 500. Now we can find out the current. The IRMS current will be equal to VRMS divided by this impedance Z. At this point, we are given epsilon is equal to 50 volt, and I think if the book has some error, it should clearly says that this voltage is RMS value. Only then you can find the IRMS as V here. So if I assume this to be RMS value, then I get the answer 50 divided by 500 equal to 0.1 ampere. And this is what seems to match with the answer given in this problem of question number 14, 0.1 ampere. But usually when you mention VE0 as 50 volt, it's typically the peak volt. For example, in this one 50 volt is, you may match the answer with RMS value. But in any case, we should understand the whole concept that we find the current using this method, V divided by G. If you want to find the RMS, if you want to find the peak value of current, then you will write peak value of this voltage divided by here. But we need to find out the RMS value of this current, and VRMS divided by G. That is going to be the answer. We assume that 50 volt is the RMS value of this voltage. And then find the potential differences across the capacitor, resistors and the inductor. To potential difference across the resistor will be this I multiplied by the resistance value. I is 0.1, resistance is 300 ohm, so this will be 30 volt. Voltage across the inductor, V is equal to, voltage across the inductor will be I into XL. XL is omega L, and this we can find 0.1. Omega is, we are known as 100, and inductor is given as 1 Henry. Let's check it. 1 Henry. So this will be equal to 10 volt, and voltage across the capacitance will be I into XC. Impedance of the capacitor is omega C. 0.1 into 1 upon omega is 100, and the capacitance is 20 microfarad, 10 to 10 power minus 6. So 2 10 to the power minus 4 goes up 10 to the power 4, but minus 1 10 to the power 3 divided by 20, this will be 50 volt. If you add these things up, 50 plus 60 plus 30, it is 80 volt, which is less than the, and this thing is more than the RMS of the supplied voltage. Note that the sum of the RMS potential differences across the cylinder is greater than the RMS voltage of the source, because it's not just the algebraic sum of the RMS voltages. L and C work in tandem. Their individual instantaneous voltage is the sum of these two voltages. And let's continue to solve the problem number 15 here. Calculate the situation of the previous problem. Find the average electric field energy in the capacitor and the average magnetic field energy stored in the coil. Find the average electric field stored in the capacitor. Electric field stored in the capacitor, if you call it U, that will be equal to half CV square. Half C is given as 20 microfarad 10 to the power minus 6, and V is given as 50. So 50 into 50. And this we can 2 cancels 10. So 1, 2, 3. So this becomes 10 to the power minus 3, and you can write as 25. 10 to the power minus 3 becomes millijoule. So that is the question number 15. And the energy in the inductor, you call it UL, half Li square. Half into L is 1, and I is 0.1 ampere here. 0.1 whole square. You can write it as 10 to the power minus 2 by 2. So make it 10 into 10 to the power minus 1. This becomes 10 to the power minus 3, or milli. This is 2, this is 5 millijoule. So this is the answer to the question number 15.